Hello guys. Okay, let's gather some viewers and then we will start this. Hmm. Okay. Today we will be continuing from lists. In part one, we completed almost 20% of lists. So let's revise that today a little, and then we will complete the whole list section. Okay, let's gather some more viewers. Now I've got my code editor open and also the terminal open here. So you guys do that. If you guys don't know how to open up a terminal and how I had set the things up, then you can watch part one where we have done the installation and set up our environment for this tutorial. Let me just run the Python interpreter. Yeah, right. Now let's talk about lists again from the start. So what are lists? Lists are like an array in Python, but they are enclosed between the square brackets, and all the basic operations can be performed, like we can print a specific, we can use the indexing like just like arrays in order to print the values. uh, Also, I showed you functions, some operations that we can perform, some methods that are by default available in lists, such as append and some values, so that we can add any value to the last of the list. We can then also use pop in order to remove the last element of the list. Also, we can do delete list tree in order to delete the fourth element of the list. Or if I want to delete the first element of the list, then I would do delete list and 0 in the index. These are some basic stuff. Let's dive a little deeper into lists. Now, here I have in my console. Okay, let me first create a list. Now, since lists can have any elements, any type of elements inside it, I will try to create a little diverse version of a list here. So let's get that started. First, let me enter an integer. Okay, then I will take a float 5.5. Then I will enter a string. This is a string, and lists can also contain a list inside them. So I'm going to create another list, 1 comma 2 comma 3. Yeah, pretty straightforward. And now we've created a list. which contains an integer, a float, a character string, and a list itself inside the list. Okay, that's some easy stuff. Now, what would we like to do? Let's first print the list. Yeah, we've got our values here. If I want to Now, what do I do if I want to access these values, these elements? I would just use the indexing, just like in arrays. If I want to print the string, since string is the third element, then string is the third element and array indexing starts from 0, then its position is going to be 0, 1, and then 2. So that means lst 2. This should do the work. Sorry, wrong. I typed the wrong variable name. Okay, string. We've got it. Let's see what we get. Print type of lst2. It's a string. Yeah, because we set it as string. String are always set inside double quotes. That's how you define that it is a string. Now we know how to access the elements, but let's see how we can access this list. Print lst. So this is going to be the first, second, third, fourth element. So 0, 1, 2, and 3. Yeah, we got the list, but we also want to access the values inside of this list. What do we do then? Let's see. We could do lst3, the fourth element of the list, and if I want to access the first element of that list, then I could do 0. Let's see what it prints. It should print 1. Okay, my mistake. I should have typed 3 here. There we go. 1. Now, if I want to print this, how would I access that? First, I would access the list. Then I would access the element inside the list. So by that definition, I would access the list. Then I would access the element inside the list, which means 1, and we have our value 2. Similarly, if I want to print the value of 3, I will do 2 and we will get the value. It's as simple as that. Okay, I hope you don't have confusion. Now let's head on. So we have learned about accessing values of the list. Now in some conditions you would you might want to take the values in a certain range. By that I mean you might want to select a certain values from inside the elements. For example, if I don't want the first and last element, okay, but I want these two elements, let's see how we can do that. In such conditions we use colon inside this indexing. Now start and end. Here we specify the value. Okay, sorry, here we specify the index of that element from which we want our range to start. So for example, if I want my indexing to start from, sorry, if I want the range of my values to start from the second element, then I would do 1 because 1 is the second element. Now then I would specify the index of the last element that I want to, last element of the range that I want to, so that I want to select. So if I do 0 1 2 3 1 2 3, then this should give me 2 3 4. Now let's try it in console. Here we have 5.5 and string and list. Let's see how we can just print the value of this and this. From second element to third element. Let's see what we get. We only got 5.5. What if I do 3? Now we get from here to here. So here I specified 0 1 2 3 up to the end element is this, and by default the indexing is going to discard this value. That's why we have to specify one step ahead. Okay, let me make a long list. Let's say lst equals to 2 3 4 5 6 7, right? Now from, in order to access the values from 2 to 4, I would do lst position 1 indexing 1, so 1 4 is going to be 0 1 2 3. Yeah, we need the value up to the third index. So I would, instead of writing 3, I would do 4 because it discards the last element. So 2 3 4, we have 2 3 4. This is also called slicing. Okay, now we know that we could also do something like this. lst 1 and leave it like that. It's going to print all the values up to the last element. Here we go. Now we can also do, if I want to print from 1 to 5, then I could do, here we go. I think you're getting the idea, right? The next thing that we would do is dive more deeper into slicing. Now, okay, one thing that's left to discuss is negative indexing. So what does negative indexing do? If I type lst -1, then it's going to print the last value. Let's see. Yeah, 7. Why? Because our first index is going to be 0. By that, -1 would mean the last element, because -1 and then 0, then 1 2 3 4 5. Just like that, if I do -2, then it should print 6. This means that the minus index always gets the value from the right side of the list. By default, if we use index 0, it takes the values from left hand side of the list, like this. Now since I am using the negative index values, it will pick from right. So -1 being this, -2 being this, -3 being this, -4 being this, and so on. We could also apply this slicing, which is in which we use the column. For example, I could do lst -1 to 0. Nothing, because sorry, 7. It should have done something like that. -3. Since it, oh, I know the problem. Since it gets started from the right hand side, I think it should be like this. Yeah, because in negative indexing, it starts from the right and ends from left. That's why we need to do this. -3, -1. Okay, now that we have covered a little some topics of indexing and slicing, let's go on to the functions that are available in lists. I've defined some basic functions before, like lst_list.append, in which we pass some values, anything, a string or an integer or a float, and it will get appended to the last element. And we could do pop, where the last element will be popped off. Now we can use pop in another context too, right? And there is also a function called remove function. And what it does is also remove element, certain element. Yeah, so we will look into it now. List.count. Meaning you can check the official documentation also. But let me see. Okay, list.pop object equals to lst -1. Mm, pop index out of range. So we just pop the element 5, right? 1, 2, 3, 4, 5, 6, 7. Let me clear this mess. Okay, let's make a list again. lst equals to 2, 3, 4, 5. List lst dot append 6. Then we appended 6. Now lst dot pop, we popped 6, the last element. So our list is going to look like this now. Now if I want to delete this 3, okay, so if I want to delete the third element, then I would have to pass an argument to the pop, because by default pop always deletes the last element. So it's places 0, 1, 2. So what happened here? Okay, so I think it counts from here, from the right side. Let's check our list now. There's no more 4 in this. What if I did now 3? If I did 3, would it delete 2? Let's see. Pop index out of range. That's a strange error. Okay, my bad, I did a pretty bad mistake here. So the pop function takes the index that we want to delete. If I say 2, then it will delete 3 because it's the third element, right? And by default the indexing starts from 0. So 0, 1, 2, and since 3 is a third element, it deletes 3. Yeah. Okay, so next thing that we will try, let's try another method. It's called list.reverse. Let me make another list from 3, 5, 7, 9. Okay, now if I want to reverse this list, dot reverse. Now if I print the list gets reversed 97531. The next thing that we could do is count how many objects. So list.count is used in order to count how many times an element is repeated. Now there is no repetition inside this list, so it should return 0. Let's see, 1, 3, 1, because 3 is return 3, the element 3 occurs inside this list only once. Okay, that's good. Now if I make a new list where 1 comma 2 comma 5 5 5 and do list dot count 5, it returns 3 because the 5 occurs, the element with value 5 occurs 3 times inside this list. Now another thing that I would show you is insert. So in insert what we do is we give the index and the object we want to insert. So if inside this list, if I want to insert 3 in the third position, then what I would do is 0 1 2. Okay, so in index 2 I would like to insert 3. Now if I print the list 1 2 3 exactly in the third position, there we go. Now if I want to remove lst dot remove 5 and let's print the list, it has removed 5. Not all of these will be get removed. The first element with the value 5 will get removed. Now let's say we want to know how many elements there are inside a list. We can just use len and list 5 because there are 5 elements in the list, 1 2 3 4 5. Another thing we could do with lists is max and lst, which will return the maximum element that is inside the list, 5, since 5 is the maximum number among these numbers, and minimum 1 because 1 is the minimum, the lowest number that we can get. Now let's talk about list. Yeah, let's talk about list operations. Let us suppose I have two lists, 1 2 and 3, and I also have another list 4 5 6. I can concatenate them. I can list 2 equals to list 1 plus lst plus lst1. If I print lst2, then it gets concatenated. These are the basic operations that you could perform. Another thing is repetition. So I want to make a list. Let's say lst equals to hello, and I do asterisk 4. Let's say asterisk 5. This means that the list is now this list is going to contain hello 5 times inside it. Let's run this and print our list. There we go. 1 2 3 4 5. So this is basically the number of times you want that element to be repeated, right? Now another thing is, uh, let's say you want to check whether an element is inside the list or not. I'll make a list named check now. Let's say 1 3 apple and mango. Now if I want to check whether apple is inside this list, so what I would do is apple in check, and this would return true because yes, apple exists inside the check. This is especially this is going to be used in if else statements, where you can check whether an element with the value you want is inside a list or not, and if it is, then you can perform certain operations, and if it isn't, then you can use the else statement to do other things. Yeah, now there's something called iteration, but we will do that after looping, after we learn loops. Yeah, so I think this covers the basics of lists. Okay. Hmm. What we want to do is let's do something with lists now. Now after lists, we will cover tuples. What are tuples? It might sound silly, but tuples are similar to lists, but the difference is once a tuple has been declared, once you specify what values are going to be inside the tuple, you can't change them. It's something called immutable. Lists are mutable. Lists are mutable while the tuples are immutable. Right? This just means that it can be changed and it can be changed. Like in a list, you can perform operations such as appending to it and removing the last element and stuff like those. And lists are declared inside, the elements of lists are declared inside square brackets, while in tuple we use small bracket to declare a tuple. Let's try that. Tup equals to 1 2 3. We've created a tuple. Let's print that we have a tuple of 1 2 and 3. Let's try appending something to it. 4. Because tuple has no attribute append, we can't add anything inside a tuple. Let's try to print the second element of the tuple, 2. Let's try changing that second element to 4. You can't because tuple item does not support assignment. What that means is you cannot change the values inside the tuple. Let's try tube.pop. No. Tuples are like lists, but you can't change anything inside it once you have declared them. Now, if you want to change it, then you will have to make a new uh, tuple. So if I want to add something to 1, 2, and 3, right? Then I would have to do tuple equals to tuple plus, let's say, 4, 5, 6. Now, sorry, we have this. We completely can't directly change them, but we will need to make another new instance of tuple. But this does mean that we can perform operations between two tuples just like lists. For example, tuple 1, 1, 2, 3, tuple 2 equals to 5, 6, and tuple 3 equals to tuple 1 plus tuple 3. Sorry, tuple 2. And then if I print tuple 3, we have all the elements. Now let's check if what happens if we do tuple 2 plus tuple 1. The elements are going to be like this. It just appends the second elements of the second tuple to the last. Same happens with lists. So you have to be careful when you are concatenating two lists or two tuples, because they might not be in the way you want. The elements might not be ordered in in the way you want. So yeah, that's all about tuples, I guess, because it's very similar to lists, but you can't perform other elements. But you can check, suppose 5 in tuple 3, it might return true because we have the element 5. And I can also do the same stuff like tuple 4 equals to hello 3 times. Now if I print tuple 4, hello, hello, hello. Okay, that was strange because I did not give comma. I'm sorry. Yeah, here it is. We can also use length, and you can't you can also apply the slicing operations like tuple 4 minus 1. This will give us the last element. 2. And also you can use compare. So tuple 1, and it takes two arguments, tuple 1 and tuple 2. So what we're doing is we are calling the compare function, and we are passing two tuples that we want to compare. So tuple 1 and tuple 2. Compare not defined. Yeah, I think there's something wrong with my interpreter, I guess. Hmm. Now let's not do that for now. Again, it just made me confused. Max and min functions also apply to get the maximum and minimum, right? And another thing that we need to know, since we know about lists and tuples, there might be some conditions that you would want to change a list into tuple and a tuple into list. I think there's a function called tuple where you, okay, let me do this again. Let me make a list. Now lists are declared, the values of lists are declared inside two square brackets, right? 1 2 3 4. Now let me declare another tuple. Tuples, the elements of tuple are declared inside two small brackets. So it's like 5 6 7 8. Now if I want to convert this list into tuple, I would do tuple lst. Now you can see here that the elements are printed inside two small brackets, which means that it has been converted into a tuple. The list is now a tuple. Now if I do list, now the tuple has been converted into list. That's it's not a big deal, but something that you should know. Type conversions, we will also discuss that later on. Now let's move on to dictionaries. Dictionary. Now what do we know about dictionary in the context of Python? The elements inside a dictionary are stored inside two curly brackets, right? And they are stored in such a fashion: key and value. Key and value. These are, you can consider this as separate elements, and they are separated by comma. We don't need to write it like this. We can use the simple convention, and let's declare a variable dict. And in the name of key, let's say 0, and it is going to take first element, the value, and let's give it 1, and this will take second element. Okay, now let's try running this in the console now. Yeah, we made a dictionary now. Let's see. Now dict 0, first element, dict 1, second element. Let's see, what if I did this? 0. What do you think this is going to print? Well, you might be thinking that this will print first element, since you have been familiar with array indexing. But no, in dictionaries, we are not calling an array index. Here we are calling the key, which is this value, right? So it's going to print the second element. Now keys are just identifiers which helps us to access the values that they are storing, that they represent. This could be something like, uh, instead of 0 and 1 I could write first and second. Now dict, if I want the second element I could do second. This will print second element. First, this will print the first element. So what this means is that the concept is like lists and tuples, but it's a little more advanced in a way that we can use identifiers and the respective values that they represent. It's a key and value concept. What that means is, now I'm using this convention so that it will be a little easier for you. Okay, just like the elements, we take this as a whole element. Okay, let us suppose this is a whole element and this is the second element. That's why we separate this with commas. And these are the actual values, and these are identifiers or keys. We use keys to identify the respective values that we want to print. Okay, now let's see. Apple, mango, and peach. We define the dictionary. Now let's, since the key of the value is first element, we use the identifier apple. It's the key to our value. That's why I'm going to use apple. It gives us first element as the value. Right now, dict peach. Now it looks for the value. It looks for the key peach, and it will give us its value, which is third element. Okay, now a more proper example would be, let's say, name, age, and class. Right? Let's say John Smith. I would need the age to be an integer for now. Let's say 7. Okay, let's say 8, and his class is going to be 5. No, let's say 2. Now let us suppose that we are accessing this data from our database, And in database, the rows and columns are going to the rows are going to have certain values to them with respect to the columns. For example, there will be a column named name where all the students name is going to be stored, an age column in which the age of those respective students are going to be stored. Now let's if we select a row, a single row from the database, it's going to be something like name. His name is going to be here, his age is going to be 8, and his class is going to be 2. Now if I want to access those, want to access that data, let's say dict, or instead of dictionary, let's also give this a proper name. Let's say student. Okay, now if I want the name, I could just type student's name. Now what? Yeah, it's case sensitive. The keys are case sensitive. That's why you need to be careful, because it needs to be exactly the same. John Smith. Want that student's name, age, it would be 8. If I want the student's class, that would be 2. Yeah. Okay, now let's suppose I want to change the existing value. I want to change the age of the student to 9. Student age equals to 9. Now if I print student, his age is 9. Also the class could have been increased. Let's say if I want to add another parameter, for example school name, and it is going to be, I don't know, something XYZ school. Let's see. Now we might have a new key and value. So this school is XYZ school. In this way we can edit the existing values. Now the thing about key and values is that it makes our life sorry, it makes our life more easier than lists and tuples, because we need to know about the exact position of the values in lists and tuples. But by using keys and values, we could just use the proper identifier and change that value. For example, I can easily change the name and age or class of the student, because the identifiers are very easy to memorize. Rather than just memorizing the position of the element, I can say, hey, change the value of the identifier age or the key age, then it will change the respective value. And if I want to add a new key and value, a pair of key and value to the dictionary, then I can do it like this. If I also student, let's add new parameter called fee, let's say 1000. Okay, 10,000. I've added a new parameter called fee, and its value is going to be 1000. Okay, so a single key can only have a single value, and other outer type of functions like len student should apply in this one too. Five, because we have, one, two, three, four, five, and another we could use is, sorry, copy clear. Let's say student copy student one equals student dot copy student one is going to get copied. What if I did student, okay, let me correct this spelling. It's going to be the same, but using this copy method is more preferable. I don't know why they both work same. They work. And we also have get this function where we, you know enter key, it gets the age. It's the same as doing, yeah. Or we can do dot keys. If you are not sure, for us, okay, let us suppose that you are not sure what are the keys, what are the identifiers of that shortened dictionary, then you can just use this function and it will show you the related keys. Now, since the keys are written in a more sensible, the identifiers have to be written in a sensible way that makes sense to the respective value that it is carrying. For example, name is storing the name of the student, so it's very logical to give the key the name as an identifier name. Now, even if another programmer comes and does pick dot keys, he will know which key he needs to use to access what values because of the respective identifier. And we can also do dict dot values. John Smith 82. Yeah, I guess this covers the basics of dictionaries. So generally we write it in this way because it makes it look more better, I guess. Instead of writing these in one single line, it's better to write it like this. And a pair of key and value is always separated by a comma as if they were a single element. Yeah, I guess that's it for today, guys. You can check the official documentation if you want to know more about this key and value. I will put a link to the official documentation in the description. Mm, yeah. Okay, guys. Peace.